Hello, everyone. Welcome to another Jakarta Tech Talk. My name is Serena, and joining us today is Rudy, who will be presenting on the topic of Jakarta EE integration testing. If you have any questions for Rudy as we move through today's presentation, feel free to ask them in the chat or use the Ask a Questions tab. Without any further delay, Rudy, over to you.
Okay, thank you.
My pleasure.
Let me start by sharing my screen so that I can have the presentation around integration testing indeed. And it's also a bit in the light of the anniversary of Jakarta EE, of course, because it exists around 5 years, apparently. So it was a good time to review maybe what is available for integration testing within the platform within Jakarta EE. So thank you for joining me. And we all know those jokes about testing, but sadly enough, there are also some issues with applications, updates that people put in production. And sadly enough, sometimes you put things in production untested, and then of course your production environment is your test environment, which goes fine most of the time, unless it goes wrong. Like maybe you remember that one major online retail store which did an update on Friday evening, and all their items, including some electronic items costing normally more than a few €100 or dollars, were for an entire weekend for sale for 99 cents. So testing is sadly enough important. So don't use your test environment as your production environment as a test environment. And there are, as you know, two levels of testing. For instance, if you look at this sentence, which contains 3 errors, then it's quite easy to spot 2 of them. 2 words of them have errors. That is something that you can easily spot with unit testing. The last 2 words have an error in it, but actually there is a third error. It's not easy to see because the sentence itself is an error. The sentence says there are 3 errors, but actually there are only 2 errors because all the rest is fine. Just want to mention that integration testing can find some other things than unit testing, so you should do also some integration testing, although that is difficult and etc. I come to that in a moment, a bit more in detail. The other classic, I could not find a better image with higher quality, but you know the idea. Those windows work perfectly fine on their own. They are tested, unit tested, but in the production situation, they are mounted that the handle of the window blocks each other. So you cannot open neither of those 2 windows. So integration testing is important. So for those who does not know me, I'm Rudy de Busser. People call me a Jakarta EE expert. I just consider myself as a user of Java EE, Jakarta EE now already for something like 15 years. So I know a few things, maybe that looks like for a lot of people that I'm an expert in that area. If you want to read more about what I'm doing around Jakarta EE or other backend development stuff, you can look there at my blog, atbash.be, or you can follow me on social platforms, of course. This is something we all know. Just want to reiterate it, that unit testing is fast and easy, but sometimes it's not really related to what your business is doing with your code. If we are creating unit tests where we supply the parameters of the functions, some values which are not really what are in the same category or the same values than what you can expect during production, then it's not always a good unit test, and people tend to just provide some value so that their code coverage, for instance, is like 90% or something, but actually that's not always related to what the business is using and how it is in production. Integration tests, they are of course much more realistic. You have an integration with all the components, and we all know that it's slow to execute, brittle, more difficult to implement, etc. What I'm going to present today is a framework especially designed for Jakarta EE runtimes. It's also generic, so it works with any runtime, but it's still a bit slow and brittle, but at least it is much easier to create them, to define them, so to check out if there is an issue where to do a remote debugging, for instance. So at least that point is solved. And if you run those tests, then for instance, every weekend, so not with every commit, but occasionally, let's say every week, then you have at least some more confidence if you put some code in production. There is, with various projects, always a discussion, how much should we test, what kind of tests should we write. So this is my view on this. You have that testing pyramid where, of course, the unit tests, you should write them, you should write a lot of them, like 70%, because they are as easy to write as any other code in most cases. Just be aware of which parameter values you are testing. Then the second level, you have those integration testing, sometimes also called component testing, API testing, or whatever. That's around 20%. And if your application has a visual front end, a GUI, then you should also spend some time on testing those parts. It's even harder than integration testing than what I'm going to present today. But yeah, try to do it in an automated way as much as possible. But yeah, as any high mountain has many times clouds around the top, because not everything can be automated in a reasonable way. Of course, everything is possible if you have time and money. But if you spend extreme amounts of time to automate those last few cases, then probably it is better than you to have just some manual testing. It's not the most fun thing to do, and you should avoid it as possible, but don't be afraid to keep some manual testing and test scenarios. Let's go to the Jakarta EE topic. It's about integration testing. So this is the list of, as you probably know, a list of all the specifications which are available in the Jakarta EE 10 platform. It's released in September, if I'm remembering correctly, with a lot of specifications around all kinds of functionality, of all kinds of needs within a classic application, from business logic, dependency injection, database access, security, etc. But there is one thing missing, if you ask me. Where is the testing? There is no specification around testing. If you look at other frameworks, products, whatever, they always include some specific parts, some functionality, some features to have your application tested with that framework or with that runtime or with that product. We don't have that with Jakarta EE 10. So last year, it's about a year that I also realized this, and I was thinking, let's start bringing together some code that I have used in various projects, have lying around on my computer, and let's try to create something for Jakarta EE integration testing, which might be someday maybe become testing 1.0. Probably not in EE11 because plans for EE11 are getting some final shape now. So not for 11, but maybe for 12. Who knows? That we have testing available there because testing is important. You all know that, especially integration testing. In unit testing is already possible with all the Jakarta EE components, etc. But integration testing is a bit missing. A quick look at what I'm going to cover today around integration testing. First of all, we are going to have a look at Weld JUnit, which is according to the definition an integration testing, but looks more like a unit testing. So it's a bit in between. So it's a good starter. I'm going to have a look at Arquillian, but mainly arguing why you should not use Arquillian if you are testing your product. And I'm going to share what my opinion is about it and why I believe that. And then, as I mentioned, last year I started working on what I called the Atbash integration testing framework, which is based on Testcontainers, is using WireMock and dbUnit, so that you have something which is usable for any Jakarta EE certified runtime, that you can run those integration testing in a uniform way, in a rather simple way, as you will see. At least I find it much simpler. I hope you find it also. So that Weld JUnit, it's for, I call it testing your business logic. It's already released a few years ago, around 2016. And the idea is that you spin up a CDI container, a Weld container in this case, and that you put there a limited set of CDI beans available, and that you can test a method or several methods which are depending on other beans that can be even mocks objects quite easily, as you will see, so that you have a possibility to test some kind of business logic which is in those methods. Code always says more than slides, especially if you are a developer. So let's have a look at an example. These examples are also available on one of my GitHub repos. I will show you the link later on so that you can start playing with this also on your own. I'm using Jakarta EE10 web API here in this case, so I put it as provided. So I'm using EE8 and EE10 today in a mixture, because whatever I'm telling you in this presentation works with 8 and 10. So this is now an example with Jakarta EE10. And I add the classic JUnit 5 dependencies. I hope that you had already the opportunity to switch to JUnit 5, because especially with those extensions, those are very nice. Mockito, as I mentioned, to create mocks, and AssertJ I'm using for those fluent test assertions. And then the Weld JUnit 5 dependency. For E10, you need version 4 of that Maven dependency. If you are working with EE8, then you have the version 2, which is compatible with that Java X namespace. Version 3 is the version for Jakarta EE9. So most people will be using version 2, I guess, or version 4 if you are on Jakarta EE10. And most of my examples today are based on this same example, so that I don't need to explain what I'm trying to do over and over again. And it's of course a simple example, but it is a bit more than a hello world. in the sense that I have here a method that calculates the amount that I need to pay each month to my bank if they lend me some money at the amount and then the time in the number of years. This is the formula. So it is not that complex, and it has one external dependency, and that's the interest rate. So if we need to pay 6% or 5%, that of course influence the amount of money that I need to pay to the bank again each month. It's a CDI bean, and I inject then here a dependent bean, where for the moment I'm just hard coding it, but of course I should retrieve it from another resource, maybe database, maybe another microservice, whatever, but it is here a bit extracted, isolated, so that I can easily change it or later on change where that value is coming from. So that's what I'm going to test. If I'm going to do it with Weld JUnit, I have a test which looks like this, where I have a class, of course, a test class, which I annotate with an extend with, so a JUnit 5 extension, which brings me the possibility that I set up my Weld container, which I will be using for this test specifically. That's my class which contains the method, and I'm adding a mock because I want to be able to specify that interest rate value. So I can, mock bean is here also from Weld JUnit. So with the builder, I can say, create me a bean, a CDI bean, which is application scoped based on this class. And when you create it, I can, for instance, specify that it needs to use this mock object, which is provided by Mockito. So this is a very nice integration of your CDI container and CDI beans, and the ability to define some mocks so that you can fake some functionality or provide some data which is normally provided by your external resource, as I mentioned it. This test becomes a CDI bean on its own, so I can inject my class which has the calculation. So calculating and testing my functionality becomes quite easy by just calling the method on the instance, providing it with values, and I have a reference value that with those two input values and the 6.99 as a interest rate value, I should have a monthly amount of around 255 euros. So if I can run this, it creates those beans for Weld. You see, it's quite fast. That the container starts up quite fastly. We only have two classes there, so it's also very swift. Verified that indeed this value is the correct value with a certain amount of error, which is due to rounding, probably. And to prove you that it's actually using this mock, and it was also for me a proof that it is actually using this mock. When I specify another value, then the test fails because it returns me another value instead of the expected value. So with this Weld JUnit extension, you can easily test some methods which are in CDI beans, which have some external dependencies, and those external dependencies you can then mock away so that you can provide custom simplified functionality in your test environment. As you have seen, with Weld JUnit, we are still more or less doing unit testing as testing a single method, although we have dependencies. So this is already an integration test, but Arquillian is probably a lot of you have either used it or at least know the name, is providing you with what they call real tests. From the website, they say we are executing for you your real tests. It's already more than 10 years old. First release was in 2011, 2012, depending on what you call the first final production release, because that's not always the one, not zero people. And project declare also something like a 0.9 as usable in production. That's of course fine, but not easy if you research then what is when the first release is there. But I have put there real tests in italic because I don't believe they are real tests, and they are not. And Arquillian itself, although it is a nice framework, is not providing you real tests, and I will argue why I believe that. So for those that do not know Arquillian, these are the main 6 steps what Arquillian does. First of all, it manages the lifecycle of the container. In 2011, container did not mean Docker container. It means that your runtime, like Glassfish, Payara, Wildfly, OpenLiberty, etc., is started at the beginning of your test class or start of your test suite and ended at the end of the suite. So it managed the life cycle of the container. And then it bundles your test case, so your test class, with some dependent classes and resources into a special archive, which is called by the shrink wrap framework. So actually, you are putting some test dependencies. If you look into what the archive contains, if you have executed that shrink wrap step, then you will see that you have some test classes included in your archive, which is deployed on the server. That is then the first thing which I don't like, in the sense that if you know the 12-factor app philosophy, is that you should move your test unaltered, your application unaltered from development to test to production, because you need to make sure that whatever you have tested is exactly the same as in production. Well, this does not fit that description, because your tests here with Arquillian are based on, if I may use the word, some crippled version of your application. It has some classes, it contains entire libraries like JUnit, which are not there in production. Then the next step, it takes that archive, it deploys it on the container. It what's called enriches the test case by providing dependency injection and other declarative service, as we have also seen by that Weld JUnit, so you can have access to your test under your class under test within your test class. And then most of the time, people are executing the test inside the container. So it is not that your tests are running or accessing some endpoints, for example, of your application and perform then the logical steps which are defined in those endpoints. No, your tests are running inside the container, and your test results are captured and sent back to the test runner for reporting. Also, that's sending back that information, especially if there is an error, that goes most of the time a bit sideways, so that you see that there is an error, but you have no idea what went wrong. And since the entire setup of Arquillian is quite complex and cumbersome, before you have a running setup, a working setup that can take some time, and the errors that you get are not always very descriptive or informative. Not going to run the entire Arquillian one. Again, that's also available on that repo. I'm just highlighting a few points that I mentioned. Mentioned there is a lot of config here. So I started from a Jakarta EE starter project, not the one which is now in the progress or is already available on the Eclipse website, but I will show you the link where I found this. There is one person who made a great effort in documenting and getting examples ready, because it is, as I mentioned, quite cumbersome. You see there is a lot of definitions that you need to specify. There are several dependency managements that you need to define, including for Arquillian. You need then to define how Arquillian is going to submit your archive to the container. Let's call it runtime. You have also plugins required to have that working. You need, as you see here, for each runtime a specific XML that specifies where the runtime is accessible, etc., because that's also different for each runtime. And then again, we are testing that loan calculator. So I can create a test for that, again, with an extension, now with Arquillian extension. Here I create that archive where I include my class. I need to include the actual CDI bean here, where I hard-coded the value. And then I need to, if I want to have some mocks, which is not really possible with Arquillian, I cannot create a mock which is then included here in that archive. So the only thing that I can do is, which is not known by everyone, I guess, is by CDI specialized beans, where you say that you're extending an existing bean and you define it as a specialization so that you can override it. And when this bean is available together with the original one, well, then this specialized version is taken. Again, this is not a normal way how your class operates, your application operates in production, because you have two beans available, which follows the same contract, the annual interest rate service here. So one of those things that I don't like. So I can inject the class under test so that I can, again, just call it. But here, this test class is not run locally here now, but is within my container, Glassfish in this example. I can also inject that alternative bean so that I can change that rate here, because I have made that adaptable in that version of that CDI bean, and I can again test that one. So it is possible. Some people are using it, and if you want to make use of it, I highly recommend the work by Hansi Bai that he has done. Maybe there is already a version for Jakarta EE10 available. On the GitHub repo, there is for each runtime there are examples available how you get a project started and that you can start creating those Arquillian tests. But another question is Arquillian still active? You can maybe discuss if it's a good approach or not, but is it active or not? Well, since 2018, if you look at the GitHub repos, there is hardly any activity going on the Arquillian repos. There is a version 1.7, which is in alpha since April 2020. And that 1.7 version is using the Jakarta namespace. So it should not be 1.7, but it should 2.0 because it's a major breaking change. But it's still in alpha because the only reason there is that version 1.7 is because of the Jakarta EE TCK tests are using, or many of them are using Arquillian. So there is no intention, because that's already in alpha for around 3 years now, so there is no intention to release 1.7. So if you're working with Jakarta E10, then probably you cannot use Arquillian unless you're fine of using that alpha version. Is then Jakarta EE TCK tests wrong that they are using Arquillian? Well, for that use case, I can more or less understand why something like Arquillian is used. Well, it was already used for more than 10 years, so switching to something else would not be easy. But on the other hand, we are also not testing real applications and functionality in our end user applications, but we are testing actually functionality of our runtimes to see if our runtime or our implementation of a specification like Jersey or for the JAX-RS implementation has the functionality which is described in the specification. So there it is another use case where I can understand why they are using Arquillian, because you can indeed create small deployments based on a few classes. So by now it should be already very clear that I don't like it because it's not testing your real WAR file. You need all those connectors which need to be maintained by the vendors, which is not always the case or not always done quickly. And it is a rather complex framework, and you can easily get the error information gets lost. So that can be sometimes difficult to find out why something is not working. And believe me, I also spent a lot of time with Arquillian, and I'm still not getting the hang of it, how I should do a few things. In that sense, you probably also know Testcontainers, and that you can run some components, as they call it, there in a Docker container. So you can run your runtime with your application in a Docker container. You can have other external dependencies like a database running in a container next to it. So in that sense, Testcontainers can provide you a better solution for integration testing, because you have the your application as is, the WAR file, which you also going to put in production, and you can provide some alternative the database setup with a very known limited set of data, for example, so that you can test your application. Yeah, you probably know the features there. So you have those repeatable tests. You can have even Selenium to test your front end, which is there a bit more stable because you have a fixed known environment, which is good. You can simulate networking issues, so that's also nice. And you can debug realistic scenarios very easily, as you will see in a moment. So this is a typical test class for test containers without any other functionality added on top of it. So just pure using test containers, which is also used in a lot of projects these days, where you define that annotation, test containers, that's the JUnit 5 extension. You have then different containers that you define, in this case, Postgres database, and your container, your runtime with your application. and you can then test your endpoint by calling it, and that retrieves, for instance, data from the database, and you have then your test here that can test if you get data back from the endpoint that you expected. But a few things which are a bit cumbersome, which requires more boilerplate is, for example, okay, we have the database here, but we need to configure then probably our data source within our application that it points to that Postgres database. Here, that endpoint, we need to ask that application container, what is your IP address, what's the mapped port, because with Docker, you always, with test containers, you always get a random port assigned so that you can have, that you can run tests in parallel, etc. So there are a few things which the developer needs to do over and over, and that can be simplified because it's always the same pattern. So that was then my idea last year. Let's start from these test containers and improve this for Jakarta EE, where we are using the simplified setup. So I was also working together with the people on the microprofile side on what's called micro shed testing, which is also abandoned now. So there is only a Jakarta EE8 version, which had that simplified setup for test containers. If you have your application, it contains a container, deploys, starts it up, etc., etc. So based on that, I started that integration testing framework. As I mentioned, it supports Jakarta EE8 and 10. It has a flexible and simple setup. You can test multiple applications, so you can either test one application, or you can even test several. If you have created several microservices, for example, that work together, you can run them all together and test them in one single environment. Okay, you can use WireMock for mocking dependencies, for examples, and there is support for databases through JUnit. I'll show you an example. It supports Payara Micro, Open Liberty, Wildfly, and Glassfish, so main Jakarta EE runtimes. It's based on the test container, so you can add other custom images with that add container because it is building on top of it. And as mentioned, I'm using also WireMock and JUnit. So let's have again that same loan calculator. This breakpoint is important. I will show you in a moment. And I have then that endpoint, which calls that where I put the values as query parameters. And this is still from my testing earlier today. So first of all, you define an annotation, JUnit 5 extension again, where you just specify there are other properties that you can define. You see there are, you can do a volume mapping, you can specify where your WAR file is located, etc. But by default, you only need to specify on which runtime you have to, that you want to run your test. You specify that WireMock container because if we are looking now, because it is also a microprofile application, if we go to the calculator here, we have our interest rate, but now it is not hard-coded anymore. It is using a REST client, a microprofile REST client interface. So it is just a reference to a service somewhere, and that service is configured here within the WAR file, but you can override it, of course, with your environment configuration. So my interest rate is now researched on a remote host called remote, port 8080, and that's the URL path. So if I would take this WAR file, this application, and I would try to access that endpoint, it will fail because it will not find this one. But it is still testable. Because In my test, I defined that it needs to start up a container that must pretend that it is that remote host. The host name of that container is is remote here. So that's already a link which is made between the two components in my test. And with this builder that I have created, you can say, well, if there is a call to that /URL, /interest URL on that remote here, then I need to reply, in this case, just with the string 5.99. That's the percentage. Again, let's take it 6 here, because those values here are for that 6.99. If I specify a string here, it just returns string. If I specify here an instance, like customer, order, person, whatever, an instance of a class, then it automatically converts it to a JSON and returns the JSON when this endpoint is called. I'm using the same microprofile REST client functionality to find out where my endpoint is. So I'm only defining the configuration, the contract. It's not the configuration. I define the contract of that endpoint here, that endpoint which is here in my production application. I define it here in the same way that I do with microprofile REST client. And actually, my frame and my integration code figures it out. What is the container in which it is running? What's the IP? What's the port, the endpoint, etc., depending on the runtime that you specify here, and it will create a implementation of that interface similar to the one of microprofile REST client, so that it actually is calling my application endpoint. So that means that I can do here a remote call. Don't be fooled about this method call. It's actually a remote call to the application endpoint. I get my data back, automatic conversion to and from JSON if needed, and then I get a comparison that I can do between the expected and the returned value. So it starts up test containers. So it creates my WAR file. It creates a Docker container. It submits that container image to the host. It can be local. I am running here Docker desktop, but if you have, for instance, the Testcontainers cloud environment, then you can run it on the cloud environment, and then it's not running locally. So it is performing all those steps, and at the end, it calls my endpoint, and I get my value back, and it is correct. Again, to prove that it is taking this value, I'm going to test out if I configure my mock to return another interest rate, if it's still okay or not. It should not be okay, so my test is now red. You see, it is still that that slow factor is still there, also because now I'm screen sharing, my fans are starting to work because I'm a bit overloading. So as I mentioned, that cloud environment might be a better solution. And then one of the things that I do automatically is then when a test fails, that you get the container log. So in this case, I take the entire log from the Payara micro container, and I'm putting it here so that you maybe have already an idea what is going wrong, why it is not what you expect. Sometimes you find that there is an issue when you start up your application because there is something missing. Then you have already here an indication by the errors that it is not working. But we can do better because we have no idea why this failed here now. Okay, it was due to the interest rate, but play along and we don't know it for the moment. So let's start up a remote debugging session. This is actually the only thing that you need to change, either for Payara Micro or for Liberty or Wildfly. And when it starts up, it says that at a certain moment it starts waiting for an additional time so that I can start just a remote debugging session. I connect my debugger locally to that port 5005, which is then actually within my container. Once the debugger is connected, my startup continues, and as expected, and I always hope that it happens, it stops at that breakpoint that I have put here. So I can see that my interest rate was 5.99, which was not the value what was expected for that test. So I can even on the fly change it here. I can continue my test. And this time it is green. So you see, integration testing becomes much easier with this framework. At least I find it much interesting. Let's switch to a database example. I have here with Open Liberty an example where I have the classic endpoints for get a specific ID, sorry, a specific company, or I can insert one. I define the GNDI for the data source here. I have then for Open Liberty that server XML where you need to specify the features. There are also other options, but I'm doing it most of the time like here with the server XML. And I also define then the GNDI name that it needs to be looking for a driver in one of those dependencies, and my framework is picking that up and make sure that the JDBC driver is copied into the Docker image at this location. Test is more or less the same. So we have here this test where I have another annotation where you can specify, for instance, a specific database, but you don't need to specify. It is discovered automatically. I'll show you in a moment. But it also specifies what they call data script files, which SQL file it needs to execute for creating the tables at the beginning of the test, which Excel file it needs to use to populate those tables. So for defining the database, you can just specify, for instance, MySQL or Testcontainer. So that's the official MySQL one by Testcontainer itself. The dependency brings in certain classes which will be detected, and the framework adapts itself to MySQL. You also need to provide a JDBC driver. That JDBC driver is detected and will be also placed within that Docker image that will be created, so that, for instance, here the reference works that in this lib directory the JDBC driver is found. We have those resources to create some tables, and we have then here that Excel file. You can specify for each test another Excel file, for example, an Excel file with the data which need to be imported in the company table here, for instance, with the ID and the names. Again, if we run it, take some time, but all the pieces are assembled for you behind the scenes. The correct container is started. By default, Testcontainers are still using a quite old MySQL, but you can update that here with that the database container image names. You can specify there yourself which image it is using so that it match. For example, your case, it has assembled all the things as I mentioned, and my add company is executed. Both are green, But as you can see, this is the endpoint that I'm calling, but I can also connect directly to the database again and ask for how many rows are there in that table. And I can even perform then a select on that table to see what's in there and match and see if the data matches what I'm expecting. So you can really do end-to-end testing. And this database connection is coming here from that abstract class here. So you have really seen it, that I extend an abstract class. So by default, that the connection to the database is available there during your test. That's kind of injection, which is done there automatically. So my preferred integration stack, what I'm doing is, well, that Weld JUnit testing there. Of course, unit testing by default, JUnit 5, that Weld JUnit. And I always use something in the past based on the Testcontainers, but now switching to my own framework there because it is most of the time easier to configure, and you can switch it even from one runtime to another. Not sure if there are any questions, but maybe first let me show me here that repo. So if you look under my name, there is a repo Jakarta Integration Testing Talk where you have those 3 examples available. So you can download that and you can start playing with it. Maybe I can look if there are any questions for the moment. I don't see any specific questions in the chat. In the ask a question, there is also empty. So I hope then that everything was clear for you. Thank you for your attention, your presence, and enjoy the rest of your day and the rest of your developing career.
Hello, can you hear me?
Yes.
Thank you so much, Rudy, for your excellent presentation. So, and there is the information that you can go and look at Rudy's blog or the GitHub. And I'm just going to take a quick look here at the Ask a Questions tab to see if there's any questions. You do have a couple of minutes to, a couple of seconds to enter any in there in the audience. So I'm going to check that there. There's no questions in there, and there's no questions in the chat. So just thank you again for the excellent presentation, Rudy. And we're looking at also to book more Jakarta Tech Talks throughout 2023. So if you're interested in presenting, you can fill out the form that I'm going to put in the actual chat. And if there's any feedback on the Tech Talk program, we would love to hear from you. So at the end of the webinar, when we close this off, just click on the green button that pops up and let us know how you enjoyed the talk. So without any further delay, thank you so much again, and you have yourselves all a wonderful rest of your day or evening wherever you are in the world. Thank you. Take care.
Yep. Bye.
Bye.